Okay, so you're here because, like me,
Yeah,
you're kind of blown away by all this AI stuff, right?
absolutely.
But especially how it's getting, well, more human-like. I mean, are we really going to have robots thinking like, well, US anytime soon?
Right. It's a huge question.
So today we're going deep.
Hmm.
Not just the headlines, but what it really takes to make a machine that makes choices like we do. And get this, it's messy.
Yeah, it's not simple at all.
Our source, a
Correct.
real deal research paper, Nature, Human Behavior. Heavy stuff, but trust me, it's fascinating.
And it's cutting edge. This isn't just like someone's theory, it's the real deal.
Exactly. So we're going to use it to understand how scientists are trying to, like, crack the code of human decision making.
Which is way more complex than just, programming a computer to follow rules.
Right. Like, think about those TCHAs online. The blurry numbers.
Oh, yeah. I hate those.
Sometimes I stare at them and I'm like, is my brain even working? What am I looking at?
And that's actually a great example of what makes human decision-making so tough to replicate. We're not always logical, we make weird mistakes, and sometimes we don't even know how we arrive at an answer.
It's true. And that's what's so cool about this study. They actually use those blurry numbers, asking people to identify them.
It sounds simple, but by looking closely at how people responded, they uncovered 6 key signatures of human performance.
Okay, so it's not just about getting the number right. There's more to it than that. What are these signatures and why are they important?
Think of them like the hallmarks of human decision-making. One signature, for example, is our inherent unpredictability. Like, even when shown the same blurry number twice, people don't always give the same answer. Our brains don't work like computers. There's always a bit of, randomness mixed in.
It's like our brains are saying, you know what, I'm feeling spontaneous today. Let's mix things up a bit.
Exactly. And that's what makes us human, right? We're not robots. And that's a crucial benchmark for AI. Can they capture that same kind of unpredictability?
So the researchers are using these signatures to see if AI can actually match these uniquely human patterns, like, is it even possible?
Precisely. They designed this really elegant experiment with human participants and then challenged several different AI models to see if they could replicate those 6 signatures. It was like a digital showdown, each AI bringing its own strengths and weaknesses to the table.
Okay, I love a good competition. So let's meet our AI contenders. First up, the star of the show, RTNet. What makes this one stand out?
Well, RTNet is really interesting because of how it's built. It uses a convolutional neural network, or CNN, which is kind of like its way of seeing and understanding images, combined with a mechanism for evidence accumulation.
Wait, hold on. Evidence accumulation. That sounds intense. Like, what's that all about?
Basically, it means that instead of jumping to conclusions based on the first thing it sees, RTNet gathers information over time, weighs the evidence, and then makes a decision. It's actually similar to how some scientists believe our own brains work.
Wow. So it's like it's trying to mimic the way humans gather clues and make inferences,
Yeah.
just like a detective.
Exactly. And that's a pretty big deal in the world of AI.
So cool. But we can't forget about the other competitors, right?
Oh, right, of course. We've got CNET, BLNet, and MSDNet, each with its own unique way of tackling this challenge.
Okay, so we've got our lineup of AI brains ready to go head-to-head with human unpredictability. I'm already on the edge of my seat. This is like a digital whodunit, trying to figure out which AI model, if any, can truly capture the essence of human thought. So how did they do? Did any of them manage to match those 6 signatures of human decision-making?
All right, so let's jump into those results. Remember how we talked about unpredictability being a key signature of human decision-making?
Yeah, like we don't always give the same answer even when we see the same thing twice.
Exactly. And it turns out RTNet, our star player, actually showed some of that same human-like spontaneity.
Wait, really? So even when it saw the same blurry number, it didn't always give the same answer. It actually made different choices.
That's right. It wasn't perfectly consistent, which, believe it or not, is a good thing in this case. It means RTNet was capturing that element of randomness that we see in how humans make decisions.
Wow, that's wild. So what about the other AI models like CNET, BLNet, and MSDNet? Did they show that same kind of unpredictability?
They were a bit more, shall we say, predictable. They tended to stick to their guns, always giving the same answer for the same input.
So more consistent, but maybe not as human-like in that specific way. Okay, interesting. What's next on our list of human signatures?
Well, let's talk about that classic dilemma we all face. Speed versus accuracy. You know, that balance between making quick decisions and making accurate ones.
Oh yeah, for sure. Like when you're taking a test and you're rushing to finish, but you also don't want to make careless mistakes.
Precisely. And it turns out all the AI models we've been talking about, they were able to adjust their speed and accuracy depending on what was prioritized in the task.
Okay, that's pretty impressive. But I'm guessing some were better at it than others.
You're right. RTNet and BLNet, they really stood out. They showed a remarkable ability to shift gears, just like humans do.
So were they like speed demons when speed was key and then more methodical when accuracy was more important?
Exactly. When the instructions emphasized speed, they responded quickly, but their accuracy dipped a bit. And when accuracy was crucial, they slowed down, took their time, and became more precise.
Smart. It's like they were adapting their strategy based on the situation, which makes sense, right? Like in real life, sometimes we need to make snap judgments, and sometimes we have the luxury of really thinking things through.
Right. Now, CNET and MSDNet, they could adapt too, but not quite to the same extent. They weren't as flexible in their response times, which suggests their decision-making process might be a bit more rigid.
Interesting. Okay, so maybe not quite as good at capturing that human tendency to either rush into things or be super careful.
Exactly. Now, remember those really tricky, noisy images the participants had to decipher? Those blurry numbers we talked about? Well, that's where we see another interesting pattern emerging.
Oh yeah, those were the ones that made me question if I even knew my numbers anymore. Do the AI models struggle with those too?
You bet. All of the models, even our star, RTNet, showed a noticeable slowdown in their response time when the images got really tough.
Okay, so even the AI models have their limits, which is kind of reassuring, actually. Like, it's not just us humans who get thrown off by a little noise.
Right. But what's fascinating is that RTNet and BLNet, they were much more sensitive to how difficult the image was. When things got really noisy, they really slowed down, just like a human would.
It's like they were saying, hold on, I need a minute to figure this out. This is hard.
Exactly. Whereas CNET and MSDNet were more like, whatever, noise, blurry image, it's all the same to me.
Huh. I love it. Okay, what else did the researchers find? What other clues can these response times give us about how these AI models are actually working?
Well, it turns out it's not just about how fast or slow they are. It's also about the overall shape of those response times, like if you were to plot them on a graph.
The shape. Okay, I'm intrigued. Tell me more.
So when you plot human response times, you typically see this kind of skewed curve. It's like a hill that slopes gently up one side and then drops off more sharply on the other.
Okay, and this shape tells us something about the underlying thought process.
Exactly. And what's amazing is that RTNet was able to replicate this human-like pattern almost perfectly.
Wow, really?
Yes, its response times had that same distinctive skewed shape, suggesting that it was actually mimicking how humans gather and weigh information over time.
That's incredible. So it's like we're seeing evidence that it's not just about getting the right answer. It's about how you arrive at that answer. And RTNet is basically showing us that it can follow a similar kind of thought process to humans.
You got it. Now, CMET and MSDNet, their response time shapes were also skewed, but they didn't quite match the human pattern as closely as RTNet did.
So they were in the ballpark, but not quite hitting a home run. What about our independent thinker, BLNet? Any surprises there?
Actually, yes. BLNet decided to chart its own course, producing response times that often had 2 peaks instead of 1. It's called a bimodal distribution, and it's not something we usually see in human data.
So it's like BLNet was saying, I'm going to do things my own way, thank you very much. I kind of admire its independent spirit. Okay, we're getting close to the finish line here. 2 more signatures to go. What about the relationship between speed and accuracy on those individual trials?
Ah, yes. This one is really interesting because you see, when humans make mistakes, they tend to be a bit slower than when they get things right. It's like we have this internal alarm bell that goes off when we're about to mess up.
That's so true. Like, if I'm rushing, I am way more likely to make a mistake. Did the AI models show that same kind of pattern?
Mostly, yes. RTNet, CNET, and even our rebellious BLNet, they all showed that classic human-like behavior. They took a bit longer to respond on the trials where they made errors.
But not MSDNet.
You guessed it. MSDNet, once again, did its own thing. It actually made errors faster than it made correct choices.
It's like it was so confident, but in a bad way. Like, it didn't even stop to think, just went with its gut, even if it was wrong.
Yeah.
I can relate to that sometimes, to be honest. But seriously, why would it do that?
It probably comes down to how MSDNet is structured. It can actually make a decision at any point in its process, and in this case, it seemed to often jump the gun, making those quick, erroneous decisions before really looking at all the evidence.
Fascinating. So even though it was designed to mimic human decision-making, it ended up revealing a totally different approach. And that's the cool thing about research, right?
Yeah.
Sometimes the most unexpected results are the most illuminating.
Absolutely.
Okay, last signature on our list. Confidence. How sure were these AI models of their answers, and did it line up with how confident we humans felt?
This one's a bit more straightforward. Humans, as you might expect, were more confident when they got the answer right.
Makes sense to me. Confidence usually comes with accuracy, or at least, thinking you're accurate.
And all of the AI models, even MSDNet, showed that same pattern. They all had higher confidence levels when they nailed the answer.
Interesting. So
Right.
even though they were all using different methods, they were all able to kind of keep track of their own performance and adjust their confidence level accordingly. That's actually pretty complex ability.
Yeah.
But so far, we've mainly been talking about how these AI models compare to the average human. What about the differences between people? Did any of these models capture that?
That is a great question. And it's where things get even more interesting because remember, we had 60 people in this study and they didn't all respond in the exact same way. Some were faster, some were accurate, some got thrown off by those noisy images. So the question is, did any of the AI models reflect that beautiful messiness of human individuality?
Oh, I hope so. That's what I want to know.
Well, you're in for a treat because this is where RTNet really shines. It not only did an amazing job at mimicking average human performance, but it also showed this remarkable ability to predict how specific people would respond to those images.
Wait a minute. Are we saying that RTNet could, predict how a particular person would react to a blurry number, even if that person was prone to making weird choices or whatever?
Yeah.
Exactly. It's like RTNet was able to pick up on those subtle individual differences in how people process information and make choices. It wasn't perfect, of course, but its accuracy was way higher than chance.
That's insane. So it's almost like RTNet was building a profile for each person, just like, a human researcher might do after observing someone for a while. Okay, that's seriously impressive. What about the other models? Were they as good at picking up on those individual quirks?
They showed some ability, but honestly, none of them came close to RTNet's accuracy.
Which makes sense, I guess, given how well it's capturing that dynamic process of evidence accumulation we were talking about earlier. It's like it's really simulating that internal dialogue we have when we're trying to figure something out.
That's a great way to put it.
Okay, so we've covered a lot here. We explored these 6 signatures of human decision-making. We saw how different AI models stacked up, and we even got a glimpse of how this research could impact everything from psychology to robotics. But let's talk about the big question everyone's thinking. Are we saying RTNet actually thinks like a person?
That's the big question, isn't it? The million-dollar question. And while like with a lot of things, it's not a simple yes or no.
Hit me with the nuance then. What's the catch?
Okay, so RTNet being able to, copy those human decision-making signatures, it's huge E. It really does tell us we're getting somewhere in building AI that can kind of think like us, at least a little bit.
Okay, but there's always a but.
Right. We got to be realistic, too. There's still things it's not doing, things we don't even fully get about ourselves yet.
So not about to have, conscious robots having existential crises just yet.
Not quite. Consciousness, sentience, that whole bag, way beyond where we're at. RTNet's amazing, don't get me wrong, but it's a tool, not like a person trapped in code.
Right. Good point to remember. As cool as it is, it's still following instructions ultimately, not having its own thoughts the way we do.
Exactly. And that's important as AI gets more complex, that we don't mix up smart with alive or anything.
Totally agree. So this research, it's opened up this door into how we work, not just machines, right?
Absolutely. Psychologists have been studying how we make choices for ages, building models, trying to figure it out.
And now this AI stuff is giving them a whole new angle on it.
Right, that evidence accumulation thing. It's not just some computer science term. Psychologists have been saying our brains do something similar for years.
So it's the AI is backing up what they thought, which is kind of wild.
Exactly. It's
Yeah.
like having this whole other way to study the brain, not just asking people questions, but building something that tries to do what brains do.
Which is insane,
Yeah.
but also kind of cool that we're at the point where we can even try that,
Oh, for sure. And here's the other thing people might miss. This isn't just some abstract thing. RTNet works on images, the real world, messy, visual stuff.
Not just numbers in a computer, but the stuff we see around us all the time.
Exactly. And that means what we learn could actually be used for things like, I don't know, self-driving cars, where AI has to make split-second choices based on what it's seeing.
Okay, that is huge. So big picture time. We've covered these signatures of how humans decide, seeing these different AIs duke it out, and it seems like RTNet's our champ. But T, even bigger, it's got folks thinking about the mind in a new way, not just robots, right?
100%. Like, this research team, they didn't just stop at, look what it can do. They said, hey, there's more to figure out about how it's stopping us thinking.
Like its stopping mechanism, how it knows when it's thought enough, even that isn't perfect yet.
Yeah. Just like us, sometimes RTNet might jump the gun, other times overthink it. Figuring that out could be the next step to even more human-like AI.
Mind-blowing. It's like we're trying to take apart the most complex thing ever, our own brains, and put it back together, but better.
And who knows what we'll find along the way. That's science for you. Each answer leads to, like, 10 more questions.
Totally. So to everyone listening, this deep dive, it's just the start. AI is changing fast, and it's not just for the super techie folks anymore. This stuff affects all of us, so keep asking questions, stay curious, because this field, it needs more brains on it, figuring out what it means to think.